A very good day to the panels and the audience. Today, I am going to present about my thesis which titled Image Quality of Powdered Fingerprint in Various Temperature Exposures. Without further ado, let's start with the presentation. What environmental factors can significantly affect the quality of powdered fingerprints? Why is it important to study the influence of various temperature exposures on the image quality of powdered fingerprints? How does understanding the impact of temperature on fingerprint quality ensure the reliability and accuracy of forensic investigations? This kind of question always come to our mind when it comes to fingerprint analysis in forensic investigations. This is also how it's become the starting point of the idea for this research. The problem statement for this research are subjectivity and human error in fingerprint grading and challenges in transforming to digital grading systems. For significance of study, this research addresses a key gap in understanding the impact of environmental factors, particularly temperature, on fingerprint recognition accuracy and reliability. By exploring optimal conditions for fingerprint analysis, it enhances forensic method and protocols, leading to more precise and reliable evidence in criminal investigation. This research contributes significantly to scientific knowledge, providing a benchmark for future studies and improvements in forensic sciences. Additionally, by enhancing the reliability of fingerprint analysis, it aims to build a public trust in forensic methodologies, thereby reinforcing the credibility and effectiveness of the criminal justice system. The objective of this research is to examine the impact of temperature exposure on powdered fingerprint for a specific duration. Besides, this research also wants to evaluate the effectiveness of human vision in observing powdered fingerprints by comparing grading score system with NFIQ system. Next, we will move on to the literature review for this research. The first literature review is Principle of Fingerprint. Fingerprints are unique to each individual, making them a reliable method for human identification. The identification process relies on unique patterns of skin ridge known as minutia, which includes features like cores, ending ridge, bifurcation, and deltas. These patterns remain unchanged throughout a person's life except in cases of chronic illness or scarring. Fingerprints contain ridges with pores that connect with sweat glands, aiding in traction and leaving identifiable prints on the surface. The classification of fingerprints falls into three main types based on patterns which are loops, folds, and arches. This classification makes our fingerprint become unique. The second literature review is Techniques to Develop Latent Fingerprint for Non-Porous Surface. There are three common techniques which are dusting, cyanoacrylate fuming, and fluorescent dye stamps. For dusting technique, it's used fingerprint powders such as black powder or grey powder to reveal latent prints on surfaces. The powder adheres to the oily residue left by the ridge of the fingers. For cyanoacrylate fumes, it will react with moisture in latent prints, creating a white polymer that adheres to the ridge. This method works well on non-porous surfaces. For fluorescent dye stamps, the fluorescent dyes like rhodamine 6G can enhance latent prints, especially when photographing them under UV light. The third literature review is Impact of Temperature on Powdered Fingerprints. To have knowledge on this, we have to know the properties of the powder used. The first property is adhesion and distribution. I will explain about the temperature variation and application challenges. Temperature variation. The adhesion of fingerprint powders to surfaces is influenced by temperature. Higher temperatures can promote adhesion, while lower temperatures can reduce it. For application challenges, excessive heat can cause the powder to become desiccated and form clumps, making it difficult to apply uniformly. Conversely, too low temperatures can cause powders to aggregate, hindering even distribution. Next properties is consistency and flow. I will explain about the powder properties and behavior. For powder properties, temperature affects the flow and viscosity of the fingerprint powders. Optimal storage conditions are dry and cool to maintain powder quality. For the powder behavior, fluctuation in temperatures can lead to changes in powder consistency, affecting its application and the quality of fingerprint visualization. The last one is volatility. We have to know what happens if temperature is high and how stable the powder is. Volatile components in the powder may evaporate more at higher temperatures, leading to changes in powder behavior and challenges in achieving uniform application. Over time, high temperature can cause the powder to deteriorate, reducing its effectiveness in developing fingerprints. For the method, grading score system and NFIQ software were used. Before I go into the details, I will tell you about the experiment flow. 6 samples of the powdered fingerprint were prepared using dusting technique by black powder on a non-porous surface. After the preparation, 3 samples were placed in a room temperature condition, meanwhile another 3 samples were placed in 80-degree temperature condition. The quality of powdered fingerprint were analyzed for 3 days using the method that I have mentioned before. For grading score system, the quality were analyzed by using naked eyes and the score were given according to the system shown below. For NFIQ software, the quality were analyzed by scanning the sample's image and the score will be generated. These are the results for both methods. And these are the interpretation of the result in the graph to compare both variable and method used. It shows that higher temperature will degrade the quality more compared to the room temperature. For the method used, it shows that the results are quite same. From the result, here are some discussions that we have to discuss. The first one is why the quality was still in good condition even 10 hours exposed to high temperature. To answer this, we have to relate the techniques that we used and the surface where latent fingerprint was found. For this research, we used dusting technique using black powder. Black powder is highly effective in visualizing latent fingerprints, providing clear and well-defined image on various surfaces, including dark and non-porous material. It is compatible with advanced techniques like TOF, SIMS analysis and DNA profiling, which enhance the evidential value for fingerprints. Additionally, black powder adheres well to fingerprint residues, ensuring clarity and detail even under challenging conditions like high temperatures. This statement supports that dusting technique is the best because the quality is still good even after prolonged exposure to high temperatures. Next, the surface that we use is non-porous surface, which is compact disc. CDs are made of polycarbonate plastic which has a high thermal stability, allowing it to withstand elevated temperature without significant deformation. The polycarbonate surface is resistant to many chemicals, preserving the integrity of the fingerprint and powder. The smooth, non-porous surface prevents powder absorption or displacement, maintaining fingerprint clarity. The fine particles in the black powder adhere well to the oils and residue left by the fingerprints on the CD surface. Additionally, the reflective aluminum layer on CDs enhance the visibility of fingerprints by providing a contrasting background. To conclude, the combination of black powder's effectiveness and durable properties of CDs ensures that the powder fingerprint remains intact and clear even after 10 hours of exposure to high temperatures. Next, we will discuss why the quality starts to degrade after 10 hours exposed to high temperature. Several factors contribute to the degradation of powdered fingerprints on CDs when exposed to high temperature over an extended period, even though their quality remains good for a long time initially. These factors include thermal expansion and contraction of the polycarbonate material, which disturbs the delicate structure of the fingerprint powder. High temperature can also cause the natural oils and residues in latent fingerprints to volatilize, reducing the binding material and causing the powder to become loose. Additionally, prolonged heat exposure can chemically degrade the fingerprint powder, reducing its contrast and adherence. The polycarbonate surface may undergo slight alteration near its glass transition temperature, affecting powder adhesion. From this combination of factors, now we know why the quality of powdered fingerprint on CDs reduces after extended high temperature exposures. This means that both endurance of black powder and CD has reached the limit because the exposure of high temperature is too long. Even before this, they can long lasting in high temperature for 10 hours. The last discussion is why the powdered fingerprint not suitable for analysis after 48 hours exposed to high temperature. Referring to the result, the average quality score for powdered fingerprint after 48 hours is 3.33. It means that the powdered fingerprint have only 1/3 of the rich detail in the print is continuous and obvious. The comprehensive analysis of various studies underscore the critical importance of capturing detailed, rich information in fingerprint analysis. The use of powdered fingerprint with reduced rich detail is not advisable due to necessity of capturing sufficient rich detail for effective comparison in forensic analysis. It means that utilizing powdered fingerprints with reduced rich detail compromises the accuracy and reliability of forensic investigations, highlighting that the necessity of advanced techniques to ensure effective visualization and comparison in criminal cases. In conclusion, temperature significantly affects the powdered fingerprint quality. At room temperature, fingerprints maintain higher quality scores, with black powder showing stable adhesive properties. However, at 80 degrees Celsius, fingerprint quality began to degrade after 10 hours due to thermal stress altering the powders and surfaces properties. By comparing naked eye observation and software observation, the study found that human vision is effective since the quality score given by human vision and NFIQ software are quite same. Therefore, this will increasingly build a trust to a transition from manual system to the new system generated by the software. Here are some recommendations for future study. The first one is increasing the number of samples. Larger sample size improves statistical power and accuracy, better capture natural variability, and ensure findings are robust and generalizable. Additionally, more samples reduce the influence of bias, enhancing the reliability and validity of the study's conclusion. Next recommendation is extend the temperature range. Future studies should investigate a broader range of temperatures, including lower and higher extremes, to fully understand the effects of environmental conditions on fingerprint quality. This would help in developing more robust methods for fingerprint preservation under various forensic scenarios. That's all for my presentation. Thank you very much.